Hello and welcome to the fifth video in this series, making simple Floppy Robin for a web browser using Cocos2d JavaScript. If you can hear a baby crying in the background, we have a 9-month-old baby, which is one of the reasons why the videos have slowed down recently. And I apologise if you can hear slight crying sound. She's having a little bit of a bad morning. Anyway, I want to in this video get quite a bit done, so for the first time we're going to have quite a bit of copy and paste. To prepare the video, you'll need to open the hello world.html because we'll need to make a small edit. And I've added in the JavaScript folder cloud.js an empty JavaScript file. And in images, I can't remember from the earlier videos whether I included all the images already in a download. For this video, I'm going to make sure I include again the robin, tree, cloud and the mountain, so that at least you've got the images needed to get up to this stage in the series. Yep, and that's it. Inside the files themselves, I've already put the include inside the HTML file to include the cloud.js. And here you can see inside the script for cloud.js, I've already defined our cloud sprite as an extension of CC Sprite. So what we're going to do then? Well, we're going to scroll clouds, mountains and trees across the screen. They're all going to be called a cloud sprite. It doesn't really matter, just different images, they behave the same way. But the way they behave is particular. So if you imagine when I click the robin now, we want it to appear it's flying. So we want to scroll objects across the screen, but we want those to appear to come onto the screen, which means the objects will start their scrolling off on this white border, let's say, off to the right hand side, and we'll keep scrolling across the left hand side until they go into the white again. And for reasons of efficiency, rather than then get rid of them, or leave the runtime to delete them for us at some point and create a brand new one, we just reset them to the right hand side off the screen and get them to scroll again, thus creating the illusion of the robin constantly flying. Now this on itself is okay, and it will actually introduce us to a new concept, which is what are called actions. But the other thing that's a slight gotcha with this is when the robin hits the floor and resets itself, we want the clouds to actually stop still in the middle of the screen and then carry on from where they left off when we click the robin again. Otherwise the effect of the robin flying is not really realistic because everything disappears. So we're going to achieve this differently to how we do the movement of the robin. You remember that the way we do the movement of the robin is we do it by using a little bit of basic physics just to calculate using some gravity and some speeds its current position, and that works out very well. With the cloud that's going to be done differently. We're going to use something called an action. An action is simply something you apply to a sprite or any object actually inside Cocos2d that inherits from CC node. And all we have to do is to say to move the cloud from the right to the left, we just call an action called move, and we give this action the destination that the sprite's moving to and the amount of time it should take. And the action function then does all the rest for us. So we're going to use an action function to get the cloud sprite to move across the screen. And then we're going to do another type of action that says when it's reached its destination point, we want to call a function which resets it to the right hand side of the screen. So we'll use another action which calls a function on the object itself. So like I said, it's quite involved. So for the first time, I'm going to do a little bit of copy and paste to keep things zipping along because I tend to babble as well. And the first thing we need for our cloud sprite are some variables. One of them is the screen width, so we know the width of the screen we have to travel. One is the speed of this cloud in pixels per second, and one is called an X offset. And what that is, that's a value that when we want the cloud to start off the right-hand screen, it will start at position of the right-hand edge plus the X offset. And when it goes across and then goes off the left-hand side, it'll go to 0 minus the X offset, so that we know that the cloud will definitely no longer be visible. We'll keep things exactly the same as the robin. So we'll make a constructor like so. And now we want to do the most, well no, not the most, we'll do the easiest function first, which is when we make a cloud, we'll set its speed and width because the clouds will be different sizes. So we're going to have its speed in pixels per second, its width and its X offset. So we know how wide the screen is. We know the X offset and the speed of the cloud. We want to then make a function called stop, and this is a function that when the robin hits the ground, like so, we want everything to stop. So I've said that the cloud will be responding to an action, which will be move in this case. Well, we want the cloud to stop. So to do that, we make a function called stop, very simple, non-imaginative name. And for this function, what we'll do is we just need to stop all of the actions, very simply called this dot and stop all actions. And that's all we need to do to stop any actions running on the cloud from continuing. The other thing we need is we've said that when the cloud goes off the left-hand side of the screen, we want the cloud to reset back to the right-hand side of the screen. So when its moving action is finished to go all the way off to the left, we want them to call a function to reset it to the right and get it to run again. So the way we'll do this is we'll make a function called reached destination, which I'm going to paste the name in here so you don't watch me typing it out forever. And inside this function, what we're going to do is we're going to, and I'm just going to type like this now, reset to right of screen. And the reason I'm doing this separately is because I want to go to the trickiest function first, which is the start function. So we've nearly got everything we need. The last function we need is the start function for the cloud. So the first thing we're going to do is we're going to make a function called start. And the very first thing, it's a little bit of a hack because it should never be needed. There shouldn't be any actions running on the cloud if we call start on the cloud. But just in case, we'll call stop all actions. And now what we need to do is we need to work out the distance that the cloud needs to travel from wherever it is. And that is this distance to minus whatever x offset is off the left-hand side of the screen. So it's very easy. All we need to do is get the x of the current position, x position of the cloud. I'm just going to make a little bit of space here now. And I've done a current x like this just to make it more clear, but here we've got the distance of the current x position minus and then the negative of the x offset, so we're going off the left-hand side of the screen. What we then need is we need the time that we're going to travel, and the time will equal then our distance divided by this dot and our pixels per second, which will give us our time that we're going to travel from whichever place we are on the screen. And this is the critical thing because it gives us our speed effectively, always consistent. And then what we need is we need to create something called destination, which is actually where we're going to. And this is a cc.p, and then we want minus this dot and x offset, and we always stay at the same y that's been applied. So what we've got then here is how far we need to travel, how long it's going to take us, and where we're going to travel to. So that'll give us the illusion on the screen that when the cloud starts again, wherever they are on the screen, they scroll across the screen with exactly the same speed as before, so there's no variation. And now we come to the most interesting part, so some completely new stuff. We have to then apply the action. So the first thing we want is our move action. So we call this action move. And this is very, very simple with the Cocos2d platform. So we just say move to, just give it the time and the destination. And that's all we need to do. We've got an action object there that we then apply to our sprite, and it will start moving for that period of defined time to this destination point. The other thing we need to do though is when we've reached our destination, we need to call our reach destination function to reset the cloud off to the right hand side of the screen again because it's gone off to the left. So we'll call this action move done. And now this equals cc, and this is a little bit trickier, this one. I see certainly a lot of posts that say this one is a bit tricky, but it's cc call func, like so. So call function, this dot reached destination. And I'm going to copy the name, paste it because I can't bother with all the capitals and things. And the object that it's applying to then, which is this. And that's the bit of syntax that doesn't work. The last thing we need to do then on this object is call run action. A-C-T-I-O-N, can't spell. And then we need to call a CC sequence, like so. And we simply need to put then our two actions inside there to run the action. So the first one we're going to do is our action move. So this is saying first of all move our sprite, and then when our sprite has completed that action, so reach its destination off the left hand side of the screen, we call our move done, which will call our reach destination function. So that's the last function that you need to complete. And the reason I left it open is because to get this to work, you need, because the sender argument, you need to know what object called this reach destination. So you need to know what the this is, and you then need to call your various functions for your object on the sender rather than this. So the first thing we do is we say sender.x is then equal to, we want to go off the right hand side of the screen, so we say sender.x offset plus sender.screen width, like so. So this will reset the cloud off to the right hand side of the screen, and now simply get everything to go again by calling sender.start. So that's all we need to do then for the cloud. That's actually everything implemented and ready to go. I need a comma in here though, don't I? And everything looks more or less all right. I hope I haven't made too many very bad errors, and that should be fairly clear how it works. We call start on the cloud, we move across the screen. If at any point the Robin crashes, we'll call stop on the cloud to stop all actions, and then when the game starts, we'll call start again, and from whatever position the cloud is in, it'll move with the same speed to the destination point. At which point we call reach destination, and it goes off to the right hand side of the screen again and starts scrolling. Okay, so some things we need then to prepare before we can implement this. We need to go into the game manager.js, and we need to add in some constants as always. And there are quite a few to drop in here. We need to scale the clouds and trees and mountains, and we need to have their restarting position, so their x offsets. And we also need to have some z indexes and some speeds inside here. So quite a few constants to add in. I recommend simply just downloading them, and in fact you can see when I was preparing I actually forgot to delete a couple that are in here. So we've got the restart x offsets already in here. For the speeds, we're going to have a fast and a slow cloud, the mountain speed and the tree speed, like so. I'm going to define some scales in here because the slow cloud will be smaller than the fast cloud to give a perception of depth. Then the other thing I want then is the z indexes. So I want z indexes for the slow and the fast cloud, which I'll drop up here. I want then z index for the tree, which I'm going to put as 50, and then I want z index for the mountain, and all designed to get everything to appear mountains behind the trees, clouds behind the mountains and everything. So everything to appear in the order that we want, like so. So you've got your Z indexes. And the last thing we need then, of course, is to include the mountain, tree and cloud images inside our resources, like this, so that we've got everything ready to call inside the game.js. So that was a bit quick there, but rather than type it all out and take loads of time, it's much more efficient just to do it this way and get it over with. So now then let's go into the trickiest part of everything, and that's game.js to actually get this all up and running. So the first thing I want to do then is I want to make a function called create clouds. So this is where we're going to, create our clouds. It does exactly what it says on the tin. And the way this will work is we'll call a function called add cloud. So we'll have a function to add a cloud to the screen, and that's actually the first function we're going to write here. And I'm going to do this again with copy and paste to keep, because things are already dragging on and I'm conscious of the time, because any videos I lose concentration after about 15 minutes. So we're going to make a function called add cloud, where we take a speed of the cloud, the position, the scale, the z index, the file name and the x offset. And the first thing we're going to do is get our screen size, because as you know we need it, and we're going to create then our cloud. I'm just going to scroll this all down a bit, creating a new cloud sprite. Now we've created that, we want to call the set speed and width function, which you remember has our speed, the screen size and the x offset, and set the cloud's current position to whatever's defined. Then we want to set the cloud's scale according to the scale if we want a small cloud, and then we can add it as a child to this layer. One more thing, however, that we do need to do inside this is we need to actually have an array of clouds. So we need to have a list of these clouds because we need to be able to scroll through them and stop them all. So the way I'm going to do this is I'm going to do it in a way I prefer to do it, which is to have something outside our game layer here called array clouds, and we'll use this to store our list of clouds. So when we've added a cloud, we want to be able then to actually add this cloud then to our array of clouds, which I will do simply like this. So whenever we want to refer to these cloud objects, we simply have to go inside the array here to do something with them. So that's then our add cloud function done. What we now need to do is we need to add the general function to create all of our clouds. And this is very easy. It just remains to call as many add cloud functions as you want to add them to the various places on your screen. We have a cloud image, first of all created, which is our file name, the cloud image. And now there really is, I would recommend just downloading this from the video link and dropping this code straight in, because it's really not worth your time typing all this out. But what we've got inside here, and in fact that seems to have wrapped and it shouldn't. What we've got, I've just turned word wrap off, sorry. Okay. What we've got then here, it looks a lot, it's not a lot. Define the file name, and here I'm calling add cloud with, it's a slow cloud. The point I want it to be added at on the screen, the scale is a slow cloud, the Z index, the file name which we have here, and then the offset X will be the X offset for this cloud. You can see that I'm adding 5 clouds, 2 mountains, and then 3 trees. A very simple function, a bit of copy and paste as I said, but keeps things short and sweet. Now what we need to do is we need to have the ability to be able to start our clouds and stop our clouds. So the first thing we're going to do is we're going to make a start clouds function, like so. And somebody's typing in C syntax, like so. And in here, all that we're required to do is loop through our clouds array and then call the start function on each of those. So we can just say for, I know there are numerous ways of looping through. I prefer to do it this way. So var I equals 0. We'll say that len equals array clouds dot length. I stays less than len, and plus plus I. So a very, very standard simple for loop that everybody's seen thousands of times. And then on each of these objects then we just have to say array clouds and I dot start. And that then calls the start function that we've seen inside our cloud object, which sets the cloud then moving with this move action here. Last but not least, the other thing we need is a stop clouds function, which does exactly the same thing. And in fact, I could have made this function taking in a bool to say whether we want to start or stop, but let's just keep it clear like this. And we just call stop on the clouds here to stop our clouds. And I ought to also name that correctly, otherwise we'll have an error. And I'm hoping we've not got too many already. Now we've done that, we need to start implementing the logic to start and stop our clouds. So where we're going to implement this then is we're going to implement this in, first of all, in the onTouchBegan. So where we set the robin actually moving, in here we want for our target to call start clouds, to start the clouds moving as well, because the game is actually going. And then where we reset the robin here, we just want to say this and stop clouds, because we want to stop the clouds because we don't want them to move anymore. We want them just to freeze in place. And last but not least, what we need to do is we need to have our creation of the clouds. So we'll do this right at the end of the initialization function. We'll just say this, and I was hoping the create clouds function would be called up by the, what did I call it? I called it create clouds like this. So this dot create clouds will call straight away in the initialization function then here, so we have the clouds on the screen. And all being well, if I now reset this, we should have some of these images on the screen. And there you can see, indeed, we do. Now resetting, you can see we've got our small clouds and our larger clouds, our mountains and our trees. And now you can see that if I start clicking, we get this distinct impression that the robin is flying, and you can see that stuff is indeed scrolling nicely across the screen. And if I let the robin die, then you can see everything freezes in place, stoppers is being called, and as soon as I click, everything starts exactly from where it left off previously. And what before looked like something not very good, where the robin was sitting on a blue canvas going up and down, now you get a distinct impression that the robin is in fact flying, the Z indexes are working, he's staying in front of the clouds, the mountains are behind the floor, the trees are in front of the mountains, so things looking all reasonably well, and it's starting to look like a bit of a game. Okay then, so that's it for this video. I apologise for the amount of copy and paste that I've done inside the video, but I'm sure you appreciate it's just to help speed it up. All the code will be available in a link for the video and info for download. Thanks again for watching, and see you in the next one.